Alright, hello everyone. In the previous unit, we talked about kinematic equations, and we use kinematic equations to pretty much predict the motion of an object before or maybe after the force being applied on that object. In this unit, we will talk about momentum. Momentum is a word that we often use in our everyday speech. It carries similar meanings to the physics definition of force. Of momentum. And the physics definition of momentum is mass times velocity. And so the equation for that is m times v. V is a vector quantity, so therefore momentum is a vector quantity. This is just a convention. Instead of putting m for momentum, which usually we use the letter m for mass, we just say p for momentum. Okay. And again, the unit for that is kilogram meter per second. So we just learn the definition of momentums, and we have to now look at what happens to the object itself when the force applied to, for example, a soccer ball, and the duration in which we apply that force. Okay, this is what happened during the collision. So there is a term for that's called impulse. Whenever there's a change in momentum, then that by definition is impulse. The equation for that is represented by letter J, the symbol J with an arrow on top, and this delta represents the change in momentum. Is equal to momentum final minus momentum starting or initial. It's equal to mv of f minus mv of I, and equal to impulse, which is the force exerted on an object over a certain duration of time. And a way to remember the definition of remember the definition of impulse is just think of change in momentum equal to the force multiplied by the time interval here. So we have a situation where you have both mass are the same, and what will happen is they both will hit. One will hit the case one, the Tesla vehicle will hit the tree. The other one is Tesla will hit a haystack. They both start at the same initial velocity. See that? Bam. So the question I have for you is which case, is it case 1 or case 2 that have the greater impulse? Pause the video, see if you can figure that out. The answer to that question is they're both going to have the same impulse. Why? Because the starting velocity for both cases is the same source the mass. And so the final velocity is 0 for both cases, and they still have the same mass. So therefore the impulse, the change in momentum is equal to each other. So they both have the same change in momentum, so therefore same impulse. Alright, we have a situation right here where the guy just jumped into this pool of water. He's fine because he increased the time of impact, so therefore decreased the force that the water decreased the force that exerted on his body, so he's fine. But in the second situation here, where this guy tried to jump in but missed the swimming pool, so therefore the force on his body is increased significantly, the time decreased. So it's not fun. He didn't die, but he hurt very badly. If you design airbags, you also have to consider impulse, because the airbags open up. It decreased the force of impact on the body by increasing the time interval in which the body in contact with the airbag. So the last video we're going to see here is a person throw an egg at a sheet, and as you can see here, the egg didn't break. Again, same concept. If you're able to increase the time of the impact, then the force exerted on the eggshell here will be reduced significantly, therefore the egg will survive the impact. Same concept as the airbag. That's all I have for you for this video. I will see you in the next video. See ya!